Hello guys, if you are online, please indicate that you're online. Please indicate that you are online. If you are online, please indicate that you are active. If you are online, please indicate. If you are active, please indicate so we can start. So we can start. Hello guys, please if you are active, please indicate. Alright, we're about to start. Please keep on sharing the group link. Keep on sharing the group link. Go to your account, copy the group link and post to your different platforms. If you have done that, just say I've done that. Indicate that you have done that. Let's keep on sharing. There are people that will need this class tonight. Let's keep on sharing. Let's keep on sharing. Let's keep on sharing. If you have shared, just indicate that you have shared. Please, please indicate that you have shared it. Please, just let me know. Just click on done, 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 done to show that you have shared. If you have shared this link, please indicate done. Indicate done so we can start. Okay, let's start. Let's continue while we wait for others to join us, right? I want to also finish up on this topic called friction today. Today will be the second class which I'll be having this topic. Then the third class, I will now conclude on this. All right, because friction is very vast, and I will try as much as possible not to go beyond your skin. All right, so pay attention because after this topic, we'll move into rotational dynamics in physics. Then we'll go into oscillations, we talk about vectors and scalar and so on and so forth. This is how we keep on meeting every day, if possible by this time, okay, every day till on the day of your exam. All right. So let's maximize every time we have. Now, yesterday we discussed on friction, right? And we talked about that. We say friction is the force of opposition. We say friction is the force of opposition. Friction is the force that tends to oppose the relative motion between two objects in contact, right? Then we'll look at the two types of friction, which are static friction and what? Kinetic friction, right? We say static friction is that maximum force that must be overcome for a body to just start to move over what? Another body. Then we say that for a body to just start to move, that means the body must have acquired a maximum static what? Frictional force, which is equal to what? The applied force. I want to do a little review so we can continue from where we start. That everybody, if have a body at rest, this is a body at rest, the body possesses a weight. The weight on the body acts downward, right? There's a force called normal reaction that acts what? Upward. Either these two forces vertically upward, they are equal but what? Opposite. One is acting down, the other is acting what? Up. Although they are equal, but they are opposite what? Direction. So for a body at rest or a body moving along the horizontal axis, the sum of these two vertical forces must be equal to what? Zero. Meaning that R plus what? Plus W must be equal to zero. That implies that R equals to minus what? W, right? So if W equals to mg, that means that R is equal to minus what? Mg, right? This is an expression to show us that these two forces, they are equal but what? Opposite. But the absolute value of my normal reaction must be that R equals to what? Mg, right? The absolute value of normal reaction must be R equals to mg. The minus sign shows that these two forces are acting in different directions. Now we say static frictional force is that frictional force that tends to keep a body at rest. The frictional force that acts on a body at rest is called static what? Frictional force. And for that body to be overcome, the applied force must be equal to what? That frictional force called what? Static frictional force. So I'm saying that for this body to just begin to move, that the applied force must be equal to what? The static what? Frictional force. At this point where these two forces are equal, we call this frictional force the limiting what? Frictional force, or limiting equilibrium. Limiting equilibrium of two what? Forces. When Fa equals to what? Fs, the word static is also known as the word limiting, right? But we cannot call a force static. We cannot call a force limiting when these two conditions are not what? Satisfied. Either. So for a static force to be limiting frictional force, the maximum force Fa, okay, must be equal to what? The static frictional force. At this moment, we have maximum static what? Frictional force, right? Maximum static frictional force. When the applied force, the force applied is equal to the static frictional force, the body will just begin to what? To move, right? Then when this applied force is greater than the static frictional force, the body will start accelerating. Is that what? All of this we discussed yesterday in our online class. So for those of you who just joined us, please do me a favor. Ensure you go back to those classes because I will not be repeating everything I said yesterday, okay? Because we have to move forward, not backward. But in everything I'm saying that there are two types of frictional force. One is one static that act on the body at rest. Number two is what we call kinetic, right? kinetic or dynamic This frictional force is a frictional force that acts on the body when the body is in what? Is in motion. Alright? Now to define this, I think yesterday I didn't define this, right? When you hear the word kinetic frictional force, it is the force that must be overcome so that a body can slide over what? Another body with a constant what? Velocity. We call this the sliding frictional force. Sorry, not dynamic. We call it sliding frictional force, right? Now let's move on to other aspects. There's a question I want us to solve from your physics textbook. This question came out some certain year like that. I want us to review this question again. Under friction. Please bear with me. Let me just get the question down. Please, if you are following, it indicates that you are following. If you are following, please indicate in the comment section. Sorry, I'm coming. Okay, page 195. Page 195. Okay, let's look at this question here we have here. The question says that an object of weight W is pulled by an angle theta above the horizontal. Find an expression for the minimum rope tension required to pull the object at constant speed, considering coefficient of kinetic friction. I repeat again, an object of weight W, an object of weight W, an object of weight what? W, the weight, this is the body here of the object of weight what? W, right? Is pulled by a rope at an angle theta above the horizontal. This object is pulled by what? A rope. A rope, okay? Along what? The horizontal, making angle theta. Find an expression, meaning the formula, for the minimum rope tension required to pull the object at constant speed. We are asked to find the tension on this rope to pull the object at a constant speed. Yesterday, we look at a case like this, right? Yesterday, where we have a body being dragged along the horizontal axis by a rope. This rope has a tension, right? And this tension can be resolved into two components, Ty and what? And Ts. Is that not? Then we say that the direction is that the Ts is acting in this direction, because since we are pulling a rope, that means this is my direction of what? Of motion. Direction of what? Of motion. All of this we discussed yesterday. I'm just trying to recap, because I saw the question and I believe that this question might likely appear again in your exam. So if the body is moving towards this direction of motion, and we are told that a body of weight W is being pulled by a rope that has a tension, and we are asked to find the minimum rope tension, meaning find the value of T, or find the formula that connects T, all right, with other parameters, or find the expression for what? For T. Now, how do we find the expression for T? T is the resultant what? Force acting on this body, right? This T can be resolved into two, which are what? Ty and what? And Ts, right? But don't forget that I said find the minimum root tension of this entire system when the body is moving with a constant what? Speed. Whenever a body moves with a constant speed, when the body moves with a constant speed, rather, acceleration is equal to what? Zero. When the body moves with a constant speed, the body is not accelerating. That means our A is equal to zero. So let's find the value of T acting on the rope when the body is accelerating with a constant what? So when the body is moving with a constant speed, right? Meaning there is no acceleration. But don't forget that we say that our Tx yesterday can be resolved as what? T cos theta, right? Yty can be resolved as what? T sin what? Theta. Okay. T sin theta. If this is the direction of motion, and we are told that considering what? Coefficient of what? Kinetic what? Friction, right? So since frictional force is involved and it's kinetic, that means this surface is a rough surface. It's a rough surface. It means there's another force here that tries to what? To oppose what? The motion of this body. Either when you're moving the body towards this direction, there's a force of what here? Opposition that tends to resist the motion of this body. That force is what? Is a kinetic what? Frictional force, because the body is in motion, right? But if the body is at rest, the frictional force acting on the body becomes what? Static. That means instead of putting Fk, I'll put Fs. But because the body is already moving with a constant what? Velocity. So that means that the body only acquires what? Kinetic what? Frictional what? Force. All right. Now let's look at this now. Sum of all the horizontal force, the horizontal forces, right, will be sum, okay, of all forces along the x-axis. We have just two forces that act along the x-axis. The first force is our Ts. The second force is what? Our Fk. But don't forget that any force that tends to move in a direction of motion or acceleration, that force is doing a positive work. So that force will be taken as what? Positive. Any force that acts against direction of motion becomes what? Negative. So that means Tx here being resolved is acting toward direction of motion. The arrow is pointing toward the same direction of motion, while Fk is always opposing it, meaning acting toward this direction. So that means the sum of all horizontal forces here is equal to Tx. Tx minus what? Minus Fk. Tx minus Fk. Now, all equals to mass times what? Acceleration along what? Horizontal axis. For Newton's second law of motion, force is defined as what? Mass times what? Acceleration. If we are considering horizontal forces along the x-axis, that means we are going to be having what? Horizontal what? Acceleration. If we are saying that F equals to ma, okay, and the force I'm considering is the force along the x-axis, it means I will have what here? Horizontal acceleration. But don't forget that this body is being dragged with a constant what? Speed, right? Since the body moves at constant speed, it means acceleration is equal to what? Zero. If A is equal to zero, that means that sum of all forces becomes what? Our Ts we already know is what? T cos theta minus Fa. Frictional force we defined yesterday from the law of friction. The frictional force is equal to what? Mu R, right? Mu R. So if I have Fk, here becomes what? Mu K what? R, right? So from here we have minus mu K what? R. Now listen, yesterday we talked about a force called normal reaction. There's a force called normal reaction that tends to act upward. Abi? The weight of the body is always acting what? Downward. And that weight is equal to what? Mg. There's a force called normal reaction. For a system like this, we say that in yesterday's class, we say that normal reaction is not equal to what? Mg. Normal reaction is not equal to what? Mg. Because we have a tensional force here. There are two forces acting upward. We have normal reaction acting upward and what? And tensional force. This Ty here is supporting normal reaction. It's as though, although we are lifting the body, we are driving the body along the x-axis. But the Ty is assisting the body a little bit. Instead of the body resting completely on the surface, Ty is supporting the body a little bit away from the surface. But the body is still being dragged along what? The horizontal surface. So since I have a force here that tends to act upward, when you drag a body along the x-axis, there are two forces that act on that body. The first force is called the vertical force. Second is what? Horizontal force. Then we have the what? The resultant what? Yeah? Tensional force. Right there? The sum of these two forces, Ty and Ts, will give us what here? T. So that means that we can resolve this tensional force into what? Ty and what? Ts. So that means my normal reaction here cannot be equal to what? Mg, because I have a force here supporting the normal what? Reaction. But for a body like this, where there is no angle or there's no rope or there's no tension, we can agree that normal reaction R is equal to what? The weight of the body. Weight is equal to what here? Mg. Because there is no tensional force. The body is not being supported. Normal reaction does not have any vertical support. So for this, normal reaction has a vertical support. So that means normal reaction here cannot be equal to Mg. But instead, we can say that the sum of all the upward forces must be equal to what? Downward forces. How many forces do we have upward? We have normal reaction, right? Plus what? Ty. These two forces here must be equal to what? This. For the body to move with a constant what? Speed. Now listen. So I can say that sum of upward forces, right? Upward what? Forces should be equal to what? Downward forces, right? Downward forces. We have two forces acting upward, which is normal reaction plus what? Ty, then equal to the weight of the body. So we can say that from the normal reaction is simply the weight minus what? Ty. Which is also same as weight is mass times what? Gravity, right? Minus what? Ty. That means my normal reaction is also equal to what? Mg minus. Okay, since we are told that the weight is W, so let me just I'll maintain the figure W, right? Let's maintain the figure W. So that means from here we can say that our normal reaction here is W minus T sine what? T sine theta. Let's call this equation 1. Don't forget when we stop here. The sum of all the vertical horizontal forces along the x-axis is what? T cos theta minus mu k r. The reason why I could not proceed, I can't just say this r is equal to mg. The reason why I have to derive this because of this component r. If not, I will have, if these two forces are the same, there will not be need for me to go through all this process. So for me to be able to define the value of r, I have to sum up the upward force, then equate them to the downward forces. So r plus ty equals to what? W. Then normal reaction equals W minus T sine theta. So from here we can say that, let's go. Here we can say that, okay, don't forget that we say all of these forces, right, is equal to what? Is 0, right? Because since the body moves at constant speed, what's our acceleration? Is 0. Here becomes Tx minus Fk equals to mass times what? 0, right? So let me just put this here. Mass times what? Times 0. Is that not? Okay. That means that, let's call this equation, let me put my 0 here, sorry for that, equals to 0, equation what? 1, Abi? Okay. So from here, we call it equation what? 2. I can then say put equation 2 into equation 1. Meaning, I want to replace the value of this r with W minus what? T sine theta. That would then give us what here? T cos theta minus mu k in bracket W minus T sine theta, right? Let's look at this again. T cos theta minus mu k, our r here is what? W minus what? T sine theta. All equals to what here? 0. All equals to 0. I can decide to expand this. Let's expand and see what another have from there. So we have T cos theta minus mu k W minus mu k times T sine theta is what? Plus what? Mu k T sine theta, all equals to what? 0. Don't forget that we are looking for the minimum group tension. We have our tension here, right? Which is T. We also have it here, right? So I'll bring these two together as like what terms. So that means here becomes what? T cos theta plus mu kt sine theta, all equals to, when you move minus mu kw to the other side, which is 0, what will it be? That will give us what, yeah? Mu k what? W. Between these two expressions, what is common is what? Is T. So we have what, yeah? T in bracket cos theta plus mu k sine theta, all equals to mu k W. Okay, let's capture this together. Now the next thing is to find T. So what do we do? Is to divide both sides by what? Cos theta plus mu k sine theta. And if that should occur, if we divide that, what do we have at the end of the day? Minimum load tension then becomes what? Mu k W divided by what? Yeah? Cos theta plus mu k sine theta. Final answer. This question came out one certain time in your past question. Please go through your past question. You will see this question in your past question. Okay? Take note of this. Let's see one more example. Please, if you're online, indicate that you're online, and let's keep on sharing the group link to others. Please, guys, keep on sharing, keep on sharing, keep on sharing. Keep on, keep on, keep on, keep on. Are you guys following at all? If you are following, please keep on sharing. Share, 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 share. Let's look at another example. Another example. All right. Another question here says that a 15-kilogram box rests on a horizontal table or surface. A 15-kilogram box. Mass of the box is 15 kilogram box. Rests on a horizontal surface. What is the minimum horizontal force that is required to cause the box to begin to slide if the coefficient of static friction is 0.35? We are given that our mu x is 0.35. All right. Question B says, what is the acceleration of the system if a person pushes the box with a force of 19 Newton if the coefficient of kinetic friction is 0.2? We are also given our mu k for the second question, which is 0.2. Now let's look at it one after the other. The first question says, a 15-kilogram box rests on a horizontal surface. So that means we have a horizontal surface here, and we have what? A 15-kilogram box. The weight of this box is downward, which is mg. Don't forget, normal reaction here R is equals to what? Mg for this diagram, because there is no tensional force. So the upward force equals the downward force, right? Then we now have to find the minimum horizontal force that is required to cause the box to begin to slide if mu x is 0.35. This is the most simplest question so far. What we are asked to find is what? The force that we need to apply for the box to begin to slide. Don't forget that for a body to begin to slide or to just begin to slide, at that moment, the applied force, right, is equals to the what? Static what? Maximum force. Don't forget, if I have a body along the horizontal surface on a rough surface, and I am to apply a force on this body to move the body has a mass, we have an applied force, right? There's a frictional force here that act on the body, which is called what? Fs. Static frictional force is that frictional force that keeps the body at rest. For this body to just begin to move, these two conditions must be satisfied. That means the applied force must be equal to Fs. When this is equal to Fs, the Fs becomes what? Limiting what? Frictional force. Sometimes, we say static also means what? Limiting. Static can only be called limiting when this condition is satisfied. We call it limiting equilibrium, whereby the applied force is equal to what? The static frictional force. At this moment, we have the maximum static frictional force. So that means that the whole of this is equal to what? Mu x what? R, right? Mu x R. For the first question, we are asked to find the minimum force rather that is needed to allow the body to just begin to work, to move. That minimum force or that force only occur when the applied force is equal to what? The static what? Frictional force. Because at this point here, the body will just begin to what? To move, right? Okay. Now let's solve this together. So from here, we can say that our applied force, which is same as what? Our Fx maximum, right? Is simply equal to what? Mu x R is what here? Is mg. So that means our applied force is equal to, we are given that our mu s is 0.35 times mass of the body is 15 times gravity is 9.81. It was given. Please take note that G, the value of G in this case was given as 9.81, right? Okay. So what we do now is to multiply, right? Is to multiply. So let's multiply out together to see what will be our final answer. When you multiply, that should be about 51.45, right? About 51.45 Newton. Let's confirm together. Please bring your calculator out. Let's punch 0.35 times 15 times 9.81. Okay, we have 51 point, sorry, this is 51.5025, right? Which is also same as 51.5 Newton. So that means that 51.5 Newton is that force that we need to make the body to just begin to work, to move. Is that clear? So that means the maximum static frictional force is simply what? 51.45 Newton. Now the next question, the next part says, the next question then says, what is the acceleration of the system if a person pushes the box with a force of 19 Newton? And we are told that coefficient of what? Kinetic friction is what? 0.2. Question says, what then is the value of our acceleration if a person pushes the box with a force? The B part here, we are given that the force here is what? 90 Newton. Is that not? 90 what? Newton. That means that, don't forget that when the applied force, I said something yesterday, when the applied force is greater than the static what? Frictional force, right? The body will start what? Accelerating. Is that not? The body will start accelerating. The body will start moving. The body will only move when this condition is satisfied. When applied force is greater than what? The static frictional force. Don't forget. But when the applied force is equal to the static frictional force, the body will just begin to what to move. There will be a jerking, all right? But when this applied force is now exceed the static frictional force, the body will start accelerating. Now we are now have to find the acceleration when the applied force is 90. Definitely, yeah, what we have here is simply what? 51.5 Newton, right? Don't forget that we say that Fa equals to Fs mass. That means that for this question, our Fs mass, Abi, is also equal to what, yeah? 51.5 Newton. So for the body to just begin to move rather with an acceleration, this force applied must exceed this. And for what we are seeing here, 90 Newton is greater than what? 51.5. So the body will definitely accelerate, right? So as the body accelerates, let's look at it together. Let me redraw the diagram again. Here we have mass of 15 kilogram. The applied force is now given as 90 Newton, right? The static frictional force we have here is 51.5 Newton. Is that not? Okay. Now let's see. The sum of all forces here becomes what? Applied force, right? Minus what? Fk. So that means that, listen, as 90 Newton force is applied, the body is now accelerating. The body has lost static and now gain what? Kinetic. That means what will be here is what? Is our Fk, no longer Fs. Because the body is accelerating, right? Is accelerating, or the body is in motion. The body is in what? In motion. So let's take it again. That means the sum of all forces becomes what? Applied force minus what? Fk equals to what? MAS. Don't forget, sum of all forces, horizontal forces, is simply the applied force minus Fk, because the applied force is moving in the direction of motion. Frictional force is acting against it. Since the applied force, which is our Fa, is in the same direction of motion, it becomes what? Positive. Fk is acting against it, becomes what? Negative. All equals to what? MAS. So that means from here, this will give us, let's work this out. Let's make our AS as what here? Subject of the formula. That will give us sum. Let's go. Our can divide both sides by mass from here, right? By mass from here. Mass can cancel mass, right? Remaining acceleration equals what? Fa minus what? Fk over what here? Over mass of the body. So from here, our acceleration of the body becomes the force applied, which is 19 Newton, minus our Fk is mu k mg, right? Fk, we say that frictional force is mu mg, right? Okay, so if I'm dealing with Fk, here will be what? Mu k mg or mu k r, right? Where r equals to what? Mg. All divided by what here? Mass. So acceleration of the body becomes, the force applied is 90 Newton. 90 minus mu k was given as what? 0.2. Okay, the mass of the body is 15 times gravity is about 9.81. All divided by the mass of the body, which is what? 15. So let's find the acceleration of the body. Please, let's keep on sharing the group link. Let's keep on sharing the group link, the link rather, the YouTube link. Keep on sharing the link from your WhatsApp group. Okay, keep on sharing the link. Let other people also partake from this class. So here we have 90 minus Let's evaluate this. We have 0.2 times 15 times 9.81. Okay. This will give us about 29.43, all divided by what? 15. So we have 90 minus, this will give us about 60.57, all divided by 15. So divided by 15, we have our acceleration as 4.038 meter per what? Second square. That is our acceleration. I hope you guys are following. I hope you are following. So we have that as 0.4.038. Yeah, that is our acceleration of the body. Okay, let's take out for another question entirely. Another question entirely. Another question entirely. All right. Are we ready? A force of 150 Newton. Next question. A force of 150 Newton pulls a 30-kilogram box to the right as shown below. If the coefficient of kinetic friction is 0.25, what is the horizontal acceleration of the box? We are given a diagram. We're having physics. We're given a diagram of this kind. The diagram is given from the question. Here we have our force here. The mass of the body is 30 kilogram. Okay. All right. Then this is a rough surface given to us. Okay. The angle of inclination here is 30 degrees. Then we have here to be. Okay, there is no force here, but this is just the diagram. Then the question says a force of 150 newtons pull the 30 kilogram box to the right as shown below. That means the force there is 150 newton. There's a force here, right? There's a force here that pulls the body, right? That pulls the body. The force is 150 newton, which is our F, right? Don't forget that we have to find acceleration of the body. Find the horizontal acceleration of the box. We are told that coefficient of what? Kinetic friction is 0.25. This is the case. The second case we saw when we have a body being dragged along the x-axis with a rope. The rope has a tension, right? Here, the angle of inclination given is 30 degrees. Is 30 degrees. So we are giving this angle of inclination and we are giving the tensional force to the 150 Newton. Now, what we do is that we are going to solve with what we have learned so far, right? Okay. All right. So let's solve. I'm going to resolve most of these forces again, so we can see how we can apply this from the beginning to the end, right? Okay. Now look at this. We have a force here called Ts. One called what? Ty, right? There's a force here called normal reaction, which is not equals to what? Mg. Then we have the weight, W equals to what here? Mg. We say that sum of the upward forces, right? Notes that R plus what? Ty is equals to what? The weight, right? Where R equals to weight minus what? Ty. We already know that the weight here is given as what? Mg minus Ty, we know is T sine what? Theta. For those who just join us, please ensure you go through the videos. We have derived all of this, okay? So the first thing I can do is that since I have my force here, this is my tension, right? My tension is given as what? 150. I can actually substitute the value here to get my normal reaction. Yes. So that my normal reaction here becomes the mass of the body is 30 times 9.8. I think, let's confirm. So before you use the value of G, always check what G is given. In this question, G is given as 9.8, not 81. Either 9.8. So let's go. Minus our T here is what? 150. Sine 30. Let's evaluate this together and see what we're going to have at the end of the day. So we have 30 times 9.8. Sorry, 30 times 9.8 is about R equals 294 minus sine 30 is 0.5, right? Times 150. That will give us minus 75. So normal reaction here is simply 295, 294 rather, minus 75. That will give us about 219 Newton, right? So let's take again 30 times 9.8. Okay. 30 times 9.8. Okay, 294. All right, so let's go. Now we have gotten this, right? Then don't forget that sum of all forces along the x-axis is equals to, we have two forces, right? There's a force here that opposes the motion, which is what? Fk, right? Then we have a force here that acts in the direction of what? Of motion, right? So that means our Ts here is positive, right? While Fk is what? Negative. So that means here becomes what? Ts minus what? Fk equals to what? MAS. In this case here, we are asked to find the acceleration. That means the body is not moving with a constant speed. So no need of saying A equals to 0, right? So for here, we can evaluate further, right? This simply implies what? Ts is T cos theta minus mu k r, right? Mu k r, all equals to what? MAS. So how do we solve for our acceleration? Is by dividing both sides by mass, Abi. So when you divide both sides by mass, that implies that the mass of the body becomes what? T cos theta minus mu k mu k r, right? T constant minus mu k r divided by what? By mass. So here we are looking for acceleration, not mass. Our AX, right, is equals to T cos theta minus mu k r divided by mass. So our AX becomes, what's our tension? We are told is what? 150, right? Cos 30 minus our mu k was given us 0.25 times. We have only solved the value of r. Are you seeing it? I don't need to substitute the value of r as mg minus t sin theta. Already I've gotten the value as what? 219. So it makes my work easy, right? Times 219, all divided by the mass of the body is 30. Now let's go. Then we have our acceleration of the body becomes let's take cos 30, 0. Cos 30 is 0.8660, multiply with 150. This is about 129.9, 129.9 minus, let's look at 0.25, 0.25 times 219. This is about 54.75, all divided by 30. This is 129, right? Okay, so let's go. 129.9. Let me take again, cos 30. Sorry, pardon me. A little cos 30 times 150. Just want to verify. 129.9. Okay. 129.9 minus 54.75. Right? This is our acceleration. Here we have 75.15 divided by 30, divided by 30 by 30. Our acceleration here is about 2.505 meter per second squared. So this is same as 2.51, right? Meter per what? Second squared. Final answer. This is how simple this can be. This is how simple this can be. Please, some of you are complaining. Are you seeing the board? Are you seeing the board? Please, are you seeing the board? I'm just seeing your comments now. Sorry, sir, I can't see anything at all. The camera is super blur. Are you seeing the board now? Please, are you seeing the board now? This is about 11:17. Person posted. I can't see. Please, are you seeing now? Are you seeing now? Please, is the board clear? Let's reply. Is the board clear now? Hello? Is the board clear? Is the board clear? Okay, someone said I should explain again. That means it simply means that you are just coming in now, right? Or okay, or maybe you didn't get the principle of this kind of body system. Now I say that we are told that we have the body kept along the x-axis, and that body is being dragged with a rope. The tensional force on that rope is what? 150 Newton. And we also find the acceleration of the body. As we are dragging the body with a rope, the body is moving, it's accelerating. So we are calculating the acceleration acquired by that body as the rope is being used to drag what? The body. So this is the body here. The body has a mass. The mass is 30 kilograms. The angle of inclination, this is the rope. When you put a rope on a body, it will incline at a certain angle to the horizontal, which is what? 30 degrees. So we have our tensional force here. The force you use in dragging the rope is always along this axis, right? Which is the hypotenuse axis. Then this force can be resolved into what? Two components, Ty and what? Ts. As we are dragging the body, the body is moving toward this direction. So that means Tx is moving in the direction of motion. If you miss this class, go back to yesterday's class, or you try as much as you can. If you can repeat the video again, because I will still upload the video on my YouTube channel. I explain everything from the beginning. Are you there? All we are just doing now is just to solve problems and all that. So Ts is going this way. This Ts and Ty, they are the two components of this force here, tensional force. When you are dragging a body, Ts is this way, Ty is this way, to meet up with this. So when you sum up Ty and Ts, we have what? T. Are you there? So Ts is acting in the direction of motion, while Fk, since this is a rough surface, that means there's a frictional force that acts against it. So we say that normal reaction is not equal to mg, but normal reaction is equal to mg minus Ty, or mg minus T sine theta, right? How do we get this formula? Is that sum of all the upward forces, we have only two forces acting upward. We have normal reaction and Ty acting upward. Then we have one force acting downward, which is what? The weight. So the sum of the two forces acting upward, normal reaction plus Ty equals to what? The downward force, right? These two forces are acting upward. This one is acting down. When you sum up the upward force, equate them to what? That of what? Downward force. So from here, we now have that R equals what? W minus Ty. Where W is what? Mg. What is that? Ty? T sine theta. Go back to my previous video, please, okay? To know how we got Ty and Ts. So my mass is 30 times. Gravity is 9.8 minus our tension is what? 150 sine 30. When we evaluate this, we have 294. This we have 75, right? When you subtract, we have 219. Since the body is moving along the x-axis, it means the body is accelerating along the x-axis. So we have to sum up all the forces acting along what? The x-axis. Since the body is going this way, that means our Ts must be positive. Ts is doing a positive work because it is moving in the direction of motion or of what? Acceleration. But Fk is doing a negative work. Frictional force always do what? A negative work. So Fk is acting against it. That is why Fk is negative here. When you are summing all the forces, that means my Ts plus minus Fk. That will now give us what? Ts minus what? Fk equals to mass times what? Acceleration along the what? Horizontal axis. According to Newton's second law of motion, that force equals to what? Ma. Ts, we define Ts as T cos theta. Fk is what? Mu kr equals to what? Mas. Our aim is to find As, which is what? Our acceleration. Now what do we do? To divide both sides by this mass, to make this As as what here? To stand alone, right? As what? As the subject of the formula, right? So when you divide through by what? By mass. Divide through by mass. Mass can cancel mass, remaining what here? T cos theta minus mu kr over what? Mass. Our T is what? 150. Cos what? Theta is what? 30 minus 0.25. Mu k is given as 0.25 because the body is moving. So we have kinetic what? Frictional force. times normal reaction we have already calculated is what? 219. Then divided by what? What's the mass here? 30. When you subtract this and divide by 30, that will give us 2.51 meter per second square. I hope that is clear now, right? Okay, we are progressing. We are progressing. We are progressing. Let's finish up this part. We are progressing. Now the next is motion along inclined plane. Inclined plane. Now listen, apart from having motion along horizontal surface, we can also have what we call motion along what? Inclined plane. And I'll be very fast about this, but I will try and hit the main point, okay? If I have an inclined plane, I want to believe we all know what's an inclined plane, right? Inclined plane in physics under machine is a machine, right? Used in lifting what? Heavy objects up up a building or up um, any any height and all that. So if I have an inclined plane at a certain what here, angle theta, then I have a body here. Place a body placed on this inclined plane. Either either the body is being pushed up, or the body is sliding down, or the body is accelerating up, or anything. We look at the conditions. Either now listen, the body itself has a weight. Every body, every object possess what? A weight. The weight of this body is acting downward. The weight is acting downward. What is what? Mg. Right? Don't forget that for horizontal, if I have a weight acting downward, there is a force acting what? Upward, that we call what? Normal what? Reaction. Likewise, this also. There is a force here that is perpendicular to the surface of this plane or of the body. This force is perpendicular this way. We call that force what? R. And it's acting this way, right? Also acting down, because this force here can be seen as a pressing force. The force that presses itself on the surface, or the force the body using exerting on the surface, can also be seen as normal reaction. In this case, we're not saying upward force equals to downward force. For this, we are saying that upward force equals downward force, right? For a system at rest, like this kind of system. Okay, but in this kind of diagram, there's nothing like upward force equals downward force, because we are dealing with what here? An incline, right? Like we saw in the other case here, if I have a rope here, right? We saw that we have Ty here, right? And here's what? Tx. In this case, we're not saying that, and we even prove that for this diagram, that R is not equal to what? Mg. That means the upward force is not equal to what? Downward force. So not in all diagrams. We have seen in the first diagram, we can say that R equals to what? Mg. In this diagram here, R is not equal to mg. Not all the time that your R must be equal to what? The downward force. Okay, so I can resolve this. I can bring out a line that is parallel with this here, just downward, a broken line here. Are you there? We have a force, a weight here. There's a weight here, right? Which is what? W equals to what? Mg. This weight here can be resolved into two components. There's an angle called angle of inclination there. This angle theta is also same as this angle here. Okay? Sorry? This angle here is equal to what? This angle here. If here is 30, here will be 30. In my last class, I was able to prove this in my last class. That these two angles are what? Are equal, right? Now, I can resolve this weight. Like we did here, we resolve this force, Abi, into what? Vertical and what? Horizontal. Likewise, this also, I can resolve this weight here into vertical. The vertical is here. Are you there? The horizontal is where? Is here. Now, in vector resolution, listen, for this diagram, when the angle of inclination is along the x-axis, don't forget yesterday's class, I said that if I'm to resolve my horizontal force, it means that our Ts will be what? T cos what? Theta. If I'm to resolve the vertical force, it means what? Ty is equal to what? T sin what? Theta. But what if the angle of inclination is found along the vertical axis? Let's say if this theta is not here, the angle is now somewhere here. That means the reverse becomes the case. If my angle of inclination is here, that means my Ts will now take what? The value of what? Of this, which is what? T sin what? Theta. While Ty will now be what? T cos what? Theta. So look at this now. This is the plane, Abi. This line is the vertical line. The angle of inclination is along what here? Is along the vertical. We don't use this to resolve. If you look at it, the weight of this body is here, Abi, forming an angle with this line. And we say that this is a vertical line that is what? Perpendicular to the surface of the body. So that means this line is taken as vertical. Then this other side is taken as what? Horizontal. Along the plane is horizontal. This is what? The vertical. Now, if the angle of inclination, or since rather, the angle of what? My inclination is along the vertical axis. That means that to resolve this force here vertically, R is equal to what? Mg cos what? Theta. Vertical will now be what? Cos theta. Don't forget. Here becomes what? R equals to what? Mg cos theta. Then resolving the same for weight, we have resolved this along the vertical. We have R equals to Mg cos theta. When you now resolve this along the horizontal plane is taken along this plane here. If I'm to resolve along the horizontal, it means along this plane. So that means that there's a force here being resolved as what? Mg sin what? Sin theta. And that force is equals to what? F what? G. Equals to Fg. Now listen. If we are dealing with a rough surface, for instance, don't forget that every rough surface, there must always have what? A force of what? Opposition. If the body is sliding down, that means there will be a force trying towards the opposite. Frictional force we tend to oppose, right? But for now, let me not define it for now. Just take note of this diagram that we have what we call the sliding The sliding force. The sliding force is also called Fg, which is equals to what? Mg sine what? Theta. Fg is called the sliding force, meaning the force responsible for sliding. Even though the object is going upward, Fg will always exist. There is a force that always wants the body to slide down. It's like, for example, now I have this body here. The weight of this body is always acting down, right? Either if I'm to release this body, definitely the body will fall, right? Now that means that there is a force that is pulling this body down. If I have a body here, there is always a force that is trying to slide down the body because of what? Force of what? Gravity. But that force is called the sliding what? Force. There is a force that presses the body into the inclined plane. That force is what? Somebody is mg cos theta, the pressing force. Also called normal what? Normal force. That normal force is R, right? Which is equals to what? Mg cos what? Theta. Please take note of this. These two forces are very important because I'll be solving so many problems with this. At the end of this class, we'll try to attempt some questions from your textbook. If you have your textbook with you, go to Friction now and look at all the exercises there. We'll keep on tackling them one after the other. The aim of this class is that at the end of each class, we should be able to solve all the exercises in your textbook, so that by the time you enter the exam hall, you will have what we call adequate knowledge to tackle any problem or anything. All of these are captured in your textbook. So please take note of this. If you are following me, say, I am following. If you are following me, say, I am following. Okay. Let's look at sliding condition. Listen. Or before we go into sliding condition, sorry, note this for me. Note this. The frictional force is equals to what? Mu R, right? This is the law, the last law of what? Solid friction. We have about 5 laws. Yesterday's class, we listed the 5 laws. The first law says friction opposes motion, right? Second law says that frictional force is independent, right, on the surface area in contact. The third one says frictional force is dependent on the nature of the surfaces in contact. The fourth one says the force of friction will increase to the same extent as the force which tends to start the motion. Is that not? The fifth says frictional force is what? Directly proportional to normal reaction. And from that fifth, we're able to derive the formula for what? Friction. The frictional force, Fr, is equal to what? Mu R, right? So if we are dealing with what? Kinetic frictional force. Kinetic. Or let's say generally for all frictional force, right? You have to take note that recall that normal reaction for this diagram. I want to define the frictional force for this diagram. Normal reaction R is what? Mg cos theta. So that implies that our frictional force is equals to mu mg cos theta. Please don't forget, if normal reaction, the pressing force or normal force is R equals to mg cos theta, and frictional force is mu R. So that means, and R equals what? Mg cos theta, right? That means what? Frictional force becomes what? Mu mg cos theta. Don't forget that if I'm dealing with kinetic frictional force, what will be here? Will be Fk, right? Fk equals to what? Mu k mg cos what? Theta. Likewise, that of what? Static what? Friction. Okay, but this is not, I just want to show us something. Just make sure you take notes of this formula here. Take note of this formula. Let's look at sliding condition. What is the condition for sliding to occur? Sliding. Of course, if we are to look at this diagram, for this body to slide down, don't forget that there is a force of what here? Opposition. Under sliding now, that means I'm dealing with what here? Kinetic what? Frictional force, right? Right? Or rather, static what? Frictional force. When the body is not moving, right? For this body to slide down, that implies that the FD, the sliding force, must be greater than what? Fx. Is that not? For the body to slide down, it means that the force responsible for sliding must exceed this force. This force is called static what? Frictional force. As this body is sliding, there's a force that tends to oppose it. So for the body to slide, but what causes sliding is that Fg is what? More than what? Or greater than what? Somebody? Fs. Sorry. Fg is greater than Fs, then sliding will occur. What we say is Fg. Fg is mg sine what? Theta is greater than Fs. What do we say is Fs again? Fs, we say that F is what? Is mu x mg cos theta, right? Don't forget that for Fx, what will it be? Mu x mg cos theta. If it's Fk, what will it be? Mu k mg cos theta. So that means here becomes what? Mu x mg cos what? Cos theta. Mg cos theta. So if that should occur, I can decide to divide both sides. I can say divide both sides by mg cos theta. Divide both sides by mg cos theta. Why am I dividing both sides by mg cos theta? I want to find the value of my mu s. What will be the value of my mu s? I will need to divide both sides by what? By this mg cos theta. That means we have mg sine theta greater than what? Mu s, abi? Mg cos what? Theta. All divided by what? Mg cos theta. Divided by what? Mg cos theta. Right? So mg can go with mg, cos can go with what? Cos theta. This can go with this, g can go with this. Sin theta over cos theta is what? Tan what? Tan theta. So tan theta must be greater than what? Somebody mu what? X. So for the body to slide, tan theta must be greater than what? Mu s. What will be the reverse of this? That means our mu s must be less than what? Tan theta. All right, so put this down. Put this down. For the body to slide. Okay. Let's look at some cases under sliding. Some cases under our sliding. If you are online, please indicate that you are online. Please, if you are following, say I am following. Please, if you are following, say I am following. If you are following, please indicate that you are following. Please, if you are following, please indicate that you are following. Okay. Okay. The first case I want us to look at tonight is, I would like to play here as well. Case one. Don't forget, our topic today, our topic now we are looking at is motion along inclined plane, right? We are still on friction, but we are looking at motion along what? Inclined plane, right? Motion along inclined plane. Now let's look at case one, where we have a block resting on a frictionless table surface, resting on a frictionless surface, on a frictionless. A block resting on a frictionless surface. This is the first case I want us to look. If I have if I have a surface here, huh? If I have a surface here and I have a body here placed here, the word frictionless means this surface is a smooth surface. We are dealing with what? A smooth surface, meaning there is no frictional force. That means the only force acting on this body will be Fg. For a frictionless surface, along the plane, the only force acting on the body is simply what? Fg. So there is no frictional force there. That means the sum, okay, let's bring out this. Here we have our angle of inclination. Here we have the weight AB, which is what? Which is our mg. Then here we can resolve this, right, into vertical and what? Horizontal. But sum of all horizontal force, horizontal forces, either, or sum of all forces rather, sum of all forces along the plane, sum of all forces along the plane is simply sum of all forces is equal to what? Fg. Why do you say it's equal to Fg? Because the only force acting on the body is what? Fg, which is the sliding force. Abi? And what do we say is Fg? Fg is what? Is mg sine what? Sine theta. All of this force is equal to what? Ma. Right? Or rather, Sum of all forces equals to Fg. All equals to what? Ma. So Fg is mg sine theta. All equals to what? Ma. So for us to find our acceleration of the body, mass can cancel mass from here. It means my acceleration is equal to what? G sine what? G sine theta. So to find the acceleration of the body, sliding down on a frictionless surface, inclined at an angle theta, the formula says what? G sine theta. Why? Because the only force acting on the body is simply what? Is simply the Fg, which is sliding. Are you there? And why do we say Fg is positive? Because this is the direction of what? Of motion, right? If the body is moving this way, that means Fg becomes positive. Any force that acts in the direction of motion is taken as what? Positive. So that means that our Fg is positive because it's acting towards direction of motion. So here we have sum of all forces equals to what? Fg equals to Ma. Mass will cancel mass. Then our A becomes what? G sine what? Theta. Okay. By now you should know what to do. G is a constant value 9.8, right? If the angle is given as 30 degrees, what do? 9.8 times sine 30. That will give you the acceleration of the body. Okay. All right, guys. So let's look at another case here. Case 2. So what do you have a block resting on a rough surface? On a rough surface. But now you can be able to visualize how the diagram will look like, right? Here we have this here. We have the body resting here, right? This force is always here, Fg. Since we are dealing with a rough surface, that means we have frictional force acting along the plane, right? So the frictional force here is what? Is Fk. Is that not? So what do? Is that sum of all the forces acting on this body, sum of all forces acting on the body. If the body is sliding down, let's consider a case whereby the body is what? Sliding down. If the body is sliding down on a rough surface, along an inclined plane, at a certain angle called what? Theta. Are you there? Since the body is sliding down, that means the body is moving towards this direction. Motion is downward, Abi. Motion is downward. Are you there? How many forces do we have along the plane? We have two forces. We have Fg and we have what? Fk. Fg is acting toward direction of motion. So Fg is taken as what? Positive. Fk is acting against what? Motion. Because the body is going this way. If the body is coming down, there will be a force of opposition this way. So Fk is opposing it, while Fg is sliding the body downward. So that means here we have Fg minus what? Fk. All equals to what? Mass times what? Acceleration. Mass times acceleration. Okay. So that implies that, let's go further. We have sum of all forces equals Fg, we know, is giving us what? Mg sine what? Sine theta. Minus our Fk. We have only defined Fk before now, that Fk is giving us what? mu k mg cos theta, right? We define fk as mu k mg cos theta. Here becomes what? Minus mu k mg cos theta, all equals to what? Na. From here, we can look at these two terms here and look at what is common among them. What is common between these two is mg. So I can factor out what? Yeah, mg. In bracket, what do we have here? We have sine theta minus. What will remain here is what? Is mu k cos what? Theta. Close the bracket. Then equals to what? Ma. I have an equal sign here. That means this mass can cancel what? This mass. What then is our acceleration of the body? Okay, let's finish off from here. Therefore, our acceleration becomes what? G sine theta minus mu k cos theta. If mass cancel mass from here, that means my A becomes what? Sine G sine theta minus mu k cos theta. This is the acceleration of the body of a block resting or sliding down, right? Sliding down, rather, the block sliding, not resting, sliding down on a rough surface. A block sliding down on a rough surface. When a block is sliding down, that means Fg minus Fk, because Fg is acting towards direction of what? Motion. Are you there? If you are there, please say you are here. You are here. Just indicate. Say, I'm following. I am following. I'm following. I will soon be rounding up. I just want to build some foundation. Then tomorrow, we solve more problems under incline. Okay? We solve more problems under what? Incline. All right. Let's look at another case here. Another case. What about this case here? A body sliding up the plane. A body sliding up the plane with a certain velocity. A body sliding up. A body. I get this case 3, right? A body sliding up the plane with an initial velocity. With an initial velocity. A body sliding up the plane with an initial velocity. No object or body will just slide up the plane. There are two conditions for a body to slide up. One is that there must be an applied force. Two is that that body will be given an initial what? Velocity. There must be a push, there must be a velocity the body is moving with. Either. So no object will just slide up. It's not possible. That I can't just have a body here and the body is just moving up by itself without a speed. So the body must have been given a particular speed, right? Now let's look at a body sliding up the plane with an initial velocity or initial speed. Okay. Now what we do to this is that my diagram is this, right? Let's watch together. Here we have our angle of inclination. We have what here? This is now my direction of motion, right? Because I'm dealing with what? A body sliding up. The body is going up this way, right? Okay, don't forget that FG is always acting downward. So if this body is sliding up, that means frictional force must act this way. So that means here we have our FK. If the body is sliding up, the body is being given an acceleration. So that means frictional force must act against motion, right? Which is acting downward. But FG is always acting downward. Either the influence of FG is not influenced rather by direction of motion. Whether the body is going upward or downward, your FG is always acting down because we call it what? A sliding what? Force. FG is called a sliding force. So from here, the sum of all these forces acting on the body will then be what? Sum of all forces will be, since motion is this way, that means FG is acting against direction of motion. It means that FG is doing a negative work on this body. Likewise for somebody, FK. Both FK and FG are doing negative work, or they are going against motion or against what? Acceleration. So that means here becomes what? Sum of all forces is equals to what here? Is equals to minus FG minus FK, all equals to mass times what? Acceleration. Because motion is upward, so FK and FG are acting downward. So both of them will be taken as negative. So sum of all forces here becomes minus mg sine theta minus mu k mg cos theta, all equals to what? Ma. Right? Don't forget that FG is mg sine theta, FK is mu k mg cos theta, all equals to what? Somebody? Ma. So from here, I can factor out, here we have minus mg is common, right? Minus mg is common in brackets. Here we have what many here? We have sine theta minus, here will now be plus, no longer minus, because I've only factored out my minus sign, right? From both. So what do we have here? We have mu k cos theta, all equals to what? Ma. So mass can cancel mass from here. We are now left with our acceleration, right? Equals to what? Our A is equals to minus G in brackets sine theta plus mu k cos theta. Our acceleration, if we factor out minus mg, that will give us sine theta plus mu k cos theta, all equals to what? Ma. Mass cancel mass. So A equals to what? Minus G, right? Sine theta plus what? Mu k cos theta. So if motion is this way, the two forces are acting this way, the ball is meant to accelerate downward. That's the normal condition. So that means what is happening here is what? Is deceleration. Is what? Deceleration. Why do we say deceleration? Because we have a negative value here. Negative means this is a negative acceleration, right? That means what? Deceleration. Negative acceleration means decelerate. Means the body is decelerating instead of what? Accelerating, right? The body is decelerating instead of the body to accelerate. Are you there, somebody? Okay. All right. So let's look at another condition. Condition for case 4. Case 4. Case 4. Let's look at a case where the body is pushed with an applied force of the plane, of the plane. Excuse me, let me get another marker. All right, sorry guys, I just have to get another marker. This is part of the challenges. Okay, okay. A case where the body is being pushed up, or pushed up, or pushed with an applied force, right, off the plane. Okay, off the plane. Now let's look at this case here. Let's say I have a plane here, right? And the body is being pushed off the plane. Okay, I have the body here. Don't forget that there's a force that acts downward, Abi, which is what? Fg. Off the plane, surface now. Okay, a rough what? Surface. Off the plane of a rough surface. Now, here it means that if I have a body here, right, and this plane is a rough surface, or is a rough surface rather, that means there's a frictional force, right, that tends to what? Oppose this. But I'm looking at a case whereby we are pushing the body upward the plane. I have a body here and I applied a force here. Let's say force up. Okay? Frictional force tends to oppose this body this way. Are you guys following? I have a body here. The body is pushed up with an applied force, or the body is pushed with an applied force upward the plane. So I'm applying a force here to push the body up the plane. So frictional force tends to what here? Oppose it. So I have what here? My frictional force. But don't forget that all the time, there's always Fg, a sliding force here called what? Somebody called Fg. So that means along this side, we have two forces, right? I have Fg, I have F up, the force applied. These first, second, and third cases we saw, we do not involve applied force. We only look at a case where the body is sliding down, right? Or the body is being given an acceleration and the body slides up. But in this case, the body is not giving any acceleration either. But we are applying a force to push the body up the plane. So that means we now have three forces acting along the plane. First force is the force up, the applied force, right? Second force is the force resisting it. Third force is the sliding force. This third force here called Fg is always there in an inclined plane. It's always, don't forget. So that means since we are applying a force up, it means the motion is this way. The motion of the body is upward. Abi, is upward. It means the body is going up the plane. Now let's look at this together. Which of these force is acting in the direction of motion? Which of these force is acting upward since we are pushing the body up the plane? The only force acting upward is simply the applied force, which is called the force up. Frictional force is acting against it. Fg is also acting downward. So I have two forces acting downward. I have my Fg and I have what? My Fk. Fg and Fk are both acting downward, but the applied force is acting in the direction of body because the body is going up as you're applying the force. So sum of all forces will then be the first force is what? Is our force up. So let's use the word Fa, right? Let's use Fa, applied force, Fa. Yeah, we're going to have what here as Fa. So Fa is acting upward minus Fg minus Fk, all equals to what? Ma. Don't forget. So sum of all these forces then becomes what? We have our Fa. This force will always be given to you, don't forget. Minus what? Our Fg is mg sine theta minus Fk is mu k g cos theta. All equals to what? Ma. So from here, we can be able to determine our acceleration. So what do? Is to divide both sides by what? By mass. Abi, divide here by mass. So a mass can cancel mass, right? We are now left with what? Acceleration of the body to be equal to what? Our applied force. From here, this so I can factorize minus mg, right? From there, that will give us minus mg in brackets. We are left with sin theta plus mu k cos theta, right? We are left with this, all divided by what? Mass. In this case, mass will not cancel mass because this applied force is not equal to Ma or mg. This applied force will be given to you as a value. So all of this is divided by what? Somebody, by mass. So please take note of this, okay? Take note of that. Let's look at another case where the body is pushed with an applied force down the plane. Now, down the plane. Still on a rough what? Surface. Down the plane. But in this case here, still on a rough surface. Okay, I hope you guys are following. So if I have this kind of question and they say determine the acceleration, I want to believe that we can be able to solve that, right? So for down the plane, it means I will remove this applied force from here. Don't forget that Fg is always there. It's a sliding force. Let's take this out. So that means if I'm forcing this down, I'm applying my force here, right? In this case here, I'm pushing the body down the plane, down. I'm applying the force to push it down. So that means the applied force and Fg are in the direction of motion. So motion is now downward. Abi? Motion is now downward. Motion is now downward. Motion is now downward. So if we apply a force down, meaning apply force, I'm pushing the body down the plane. So Fg and Fa are acting down the plane, right? There is a force of opposition. Where do you think the force will now be? Will the force be acting down and also? No. Frictional force is called force of opposition. If the body is moving downward with this applied force, that means our Fk will move this way. Fk will act upward. If Fa is acting downward, Fk must act what? Upward. But don't forget that our Fg is always acting what? Downward. So since the direction of motion is downward, that means both Fa and Fg will be what? Positive. Because Fa and Fg are acting in the direction of what? Of motion. They are acting in the direction of motion, right? Which is downward. But Fk is acting against it. That means sum of all forces, right? Sum of all forces will then be what? We have, okay, we are looking at downward, right? We have our Fg, which is acting down, plus what? Fa. Or let me start with my Fa. Fa plus Fg minus what? Fk, all equals to what? Ma. So sum of all these forces here becomes Fa will be given. Fg is always mg sine what? Theta minus mu k. Fk is mu k mg cos theta. All equals to what? Ma. So from here, we can be able to determine our acceleration by dividing both sides by what? By m. Abi? When you divide both sides by m, mass over m over what? M. Mass can cancel mass from here, right? So our acceleration of the body then becomes what? The applied force plus, looking at these two expressions, what is common here is simply what? Mg, right? So I can say plus mg in brackets. Here becomes what? Sine theta minus mu k cos theta. All divided by what? By mass. This is the expression for a body being pushed down the plane on a rough surface, inclined at an angle what? Theta. Where Fa, this F here is the force down, right? Don't forget the force down. In some cases, they can use here as what? As Fg. Fg means what? Force down. So anywhere you see Fa, just put Fg, right? It means what? Fg. It means what? Fg, right? You can use Fa or Fg, anyone. All you need to just note is that just know how to define the force. If the body is being pushed down, so you know that any force here is the force you are applying to push the body down the plane. Alright? So let's see if we have other case. If we have other case. Alright, we are rounding up now. We are rounding up already. We are rounding up already. Okay, I want to summarize with something. Then we can now round up. Summary. 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 We say we have what we call condition. The first summary is that condition for sliding, right? Sliding. What do we say is the condition for sliding? That Fg must be greater than what? Fs, right? Fg must be greater than what? Fs. Or I can say Fg must be greater than Fk. Since we are dealing with sliding, please correct this. This should be Fg must be greater than what? Fk, right? And here we say that our mg sin theta must be greater than our Fk here is what? Mu k mg cos theta. Okay, please correct this. Condition for sliding is that Fg must be greater than Fk. The body will keep on sliding. Alright? Okay. So that's the condition for sliding. So from here we say that M can cancel M and B. G can go with G. So we are left with sin what? Theta greater than what? Mu k cos what? Theta. Is that not? So we say our mu k is simply, okay, yeah, we now divide both sides um, by cos theta, right? By cos theta over what? Over cos theta. So that this can go with this, right? So say tan theta must be greater than what? Than mu k. Is that not? Or mu k must be less than what? Than theta. This is the condition for what? Sliding. Number 2 is condition for just sliding. For just sliding. These are not the same terms. These are not the same terms. Condition for sliding means Fg is greater than what? Fk, right? Condition for just sliding is that Fg must be greater than what? So I'm coming, let me just get something. Okay. Condition for just sliding is that the value of our Fg must be equal to what? Fx what? Maximum. Let me explain this. Now listen. For the body to just begin to move, like we say, Fg must be what? Equal to what? Fs mass. Meaning the body is now moving with a constant what? Velocity. For just, when the body just begin to what? To slide. Condition for just sliding is different from condition for what? Sliding. Sliding only takes place when Fg exceeds what? Frictional force, right? But condition for the body to just begin, the first slide, there must be a just begin, is that Fg must be equal to what? Fx what? Mass. What's our Fg? Fg here is what? Is mg sin theta, all equals to what? Our Fs here is what? It's mu s mg cos theta. Don't forget, right? The Fs is mu s mg cos theta. If I have Fk, what will it be? Mu k mg cos theta. By the time we divide both sides by what again? Okay, let me just cancel from here. Mass cancel mass. G cancel what? G. We are left with what here? Sin theta equals to what? Mu s cos what? Cos theta. So divide both sides by what? We now divide both sides by cos theta, right? By what? By cos theta. Cos theta can cancel cos theta. What the ratio of sine over cos is tan, abi? That means that our mu s is equals to, our mu f is equals to what? Tan what? Tan theta. Now listen, when mu f is equal to tan theta, that means this tan here, this theta rather, is called the angle of repose. The angle of what? The angle of repose. The angle of repose is called the angle of repose. Repose. Either it's called the angle of repose. The angle of repose is the angle, is the maximum angle made when Fg is equal to what? Fs. Listen, when Fg is greater than Fk, we have tan theta is greater than what? Mu k. This angle here is not the angle of repose because Fg is greater than what? Fk. But when your Fg is equals to what? The static rotational force, okay? The angle form here is called angle of what? Of repose. Now let me define angle of repose for those of you who are online. Angle of repose is the maximum angle of inclination at which a body placed on a rough plane is just about to slide down under its own weight. Angle of repose is the maximum angle of inclination at which a body placed on a rough surface, on a rough plane, is just about to slide down under its own weight. All right? That's called the angle of what? Repose. An angle of repose is gotten when Fg, the sliding force, or the sliding force rather, is equal to what? The maximum static what? Frictional force. That is Fs mass. When these two forces are what? Are equal, the angle form is called what? The angle of repose. Let me see how I can illustrate this, okay? Using a diagram. Then I will summarize this class. Listen, if I have this, some of you have already done some experiment in the lab, right? Let's say I have a body here. Listen, I have a body here, and in the lab you'll be asked to lift. This is the height of the inclined plane. This is our height. Is that clear? Okay. The distance is from here to here. The distance covered. The distance the body gives the moving along the plane is from this point, right? This point here, sorry. This point here, point A, B, and what? And C. Either. Now, for this body to slide, in the particle, or you'll be asked to lift the inclined plane or increase the height. Do you get the concept? Let's say if my height is, sorry, if our height is 20 meters, the body might not slide. But by the time we increase the height to 25 or 30, the body will just begin to, that point where the body just begins to slide, the body just begins, the body has not started sliding, the body is about to slide. What happens there is that Fg is equal to what? Fs mass. So the angle formed at that moment when you have a new height and the body is about to slide, that angle form is called what? Angle of what? Repose. It's called angle of what? Repose. We use theta r, which is same as what? The angle of repose. So the angle of repose is the angle form when Fg is equal to what? Fs. And I define that again. Angle of repose is the maximum angle of inclination at which a body placed on a rough plane is just about to slide down under its own weight. We have condition for angle of repose. One is that there is no applied force. Are you there? Number two is that the body is just about to what? To move. Number three is that static frictional force is at its maximum value. Number four is that the body is in its limiting equilibrium. Condition for having angle of repose. Let me write and I will summarize and we will end this class. Condition for having angle of repose. Number one is that there is no external force. There is no apply force, okay, or external force, apply force. Number two is that the body is just about to move. The body is just about to what? To move. Number three is that static frictional force is at its maximum value. Static frictional force is at is at maximum value. Maximum value. Number four is that the body is in its limiting equilibrium. The body is in its limiting equilibrium. Hope you know what we mean by limiting equilibrium. Equilibrium, limiting frictional force, talks about when Fg equals to what? Somebody Fs maximum. Like under the normal inclined plane, we have our limiting frictional force. When the applied force is equal to the static frictional force or the static maximum force, right? Or the maximum static frictional force. When the applied force equals to the frictional force, the static frictional force, that static frictional force becomes what? The limiting frictional force. But for inclined plane, the body is in its limiting equilibrium. Simply means that Fg is equal to what? Fs1 maximum. Where Fg is what? Mg sin theta. Fs is what? Mu s mg cos what? Theta, right? Then from there we have our angle of repose. If mu s is equal to tan theta, how do we find this angle of repose? Angle of repose will be calculated by finding what? The tan inverse of what? Of mu s. Tan inverse of mu s will give us the angle of what? Repose. Don't forget that every other angle are not called angle of repose. Angle of repose is just one condition, and that condition is when the sliding force is equal to what? The static maximum force. So in our next class, all of this we have seen, all of these cases we have seen, will solve all the exercises in your textbook. Why I have to go deeper this way is because I've gone through your textbook, I've gone through your past questions. This is the level you have to get to, all right, to be able to solve those questions in your past questions, all right. So I want to wish you guys uh, happy reading. Make sure you study everything we have learned, and make sure you try to solve some problems by yourself. We meet tomorrow morning again at the center, right? We meet in the morning rather at the center by 8 a.m. for intensive class in chemistry and mathematics. Make sure you are with us tomorrow. For those of you who are in Imo State University, see you in class tomorrow. All right. So tomorrow we meet again. By this same time, by 10 p.m. tomorrow, we meet to finalize on this class. All right. The last class will not be on pulley system. Friction along what? In a pulley system. Okay? In a pulley system. That'll be the last class. All right? We'll look at this topic in detail. So that no matter how into we set your exam, you guys will be able to attend and solve all the problems. All right? So we'll meet again tomorrow. Thank you so much, guys. Thank you so much, guys. Please, if you have any question, you can ask. I think I have to wait a little for those that have questions to ask their question. If you have any question, you can ask in the comment section. Please ask your question. Please ask your question. Ask your question. If you have any question, you can ask your question. All right, I think there is no further question, right? There is no further question. So let's meet tomorrow. So thank you guys. I really appreciate your time. All right. God bless you all.